Okay, so for today, guys, that's gonna be data production strategies. So welcome to the data protection strategies practice lab. In this module, you will be provided with the instructions and devices needed to develop your hands-on skills. Data protection strategies are implemented to protect the confidentiality, integrity, and availability of the production data. These strategies are through implemented to protect the confidentiality ability of these strategies are implemented through risk management to protect the data from cyber threats, maintain customer trust, and comply with laws and regulation. In this module, you will explore the data protection strategies of encryption, hashing, and code obfuscation. So, learning outcomes. In this module, you will complete the following exercise. Exercise 1 encryption, exercise 2 hashing, and exercise 3 obfuscation. So after completing this module, you should be able to encrypt a file, encrypt a folder, conduct hashing in Windows, conduct hashing in Linux, execute JavaScript code, and obfuscate and execute JavaScript code. So exam objectives. The following exam objectives are covered in this module. Com- Compare and contrast concept and strategies to protect data. General data considerations, method to secure data. Okay, so for exam objectives, the following exam objectives are covered in this module. Compare and contrast concepts and strategies to protect data. General data considerations and method to secure data. So lab duration, it will take approximately 1 hour to complete this lab. So click next. So lab topology. During your session, you will have access to the following lab configuration. Depending on the exercise, you may or may not use all of the devices, but they are shown here in the layout to get an overall understanding of the topology of the lab. So ACID C01, ACID M01, ACI Win11, ACI Alma, and ACI Kali. So click next. So exercise 1, encryption. Encrypting File System or EFS is a Windows operating system tool that allows users to encrypt individual files and folders. EFS can be used through the File Explorer or in a command line using the Cipher command. EFS integrates seamlessly with the Windows NTFS Windows file system, allowing for the secure storage and retrieval of encrypted files. In this exercise, you will conduct file and folder level encryption from Windows Explorer and the Windows command prompt. So after completing this exercise, you should be able to encrypt folder and encrypt a full file. So your devices, you will be using the following devices in this lab. Please power this on now, ACI DC01 and ACI Win11. So encrypt a file for task 1. So Cipher.exe is a command line tool that encrypts and decrypts file and folders on the NTFS file system. Once a file or folder is encrypted, the keys are associated with the user account that performed the encryption. This means that a user's encrypted file will not be readable from another user's account, and that any encrypted file will automatically be decrypted if it is opened from the user's account that conduct the encryption. In this task, you will use cipher.exe to encrypt a file. So connect to ACI Win11. So File Explorer, then PC, this PC, ACI HD. So documents, folder 10, and then the navigation path, type the following CMD, hit enter. And then step 4, type the following and press enter. So echo space this is a new file. New file .txt. Enter. So in the command prompt window, type the following and then press enter. So cipher slash e space c users add administrator documents module underscore 10 underscore folder space slash new file .txt, and then hit enter. So step 6, observe that the new file txt was encrypted. The E in the command use is to encrypt specific files or directories. The D switch will be used to decrypt the file. In the File Explorer window, tap the taskbar. And then observe the new file txt file has a lock on its icon indicating that it has been encrypted. So keep the File Explorer window open. So task 2, encrypt a folder. As encryption is done on the file level, encryption can occur on the folder level using EFS. In this task, you will use File Explorer to encrypt a folder. So step 1, connect to ECI Win11 where the File Explorer window is open. So File Explorer, navigate this PC and then Documents, Folder 11. I'm sorry. Right click Folder 11 and select Properties. So click Advance. Then tick the checkbox next to encrypt contents to secure data and click OK. Then step 4, click OK. Then click OK. Then double click. Then since the icon in this file folder Explorer are small, it is difficult to see, but the module 11 folder now displays a lock on its icon, indicating the folder has been encrypted. In File Explorer, select View, then select Extra Large icon from the drop-down menu. So observe with the extra large icons that there is a lock on each of the files indicating they are encrypted. Close the File Explorer window. So exercise 2, hashing. So hashing is a cryptographic process that creates a unique representation of any size data in a fixed size string of characters. Hashing is used to verify the integrity of files, folders, and volumes of information because if anything associated with that hash data changes, the subsequent hash output will also change, indicating a change has been made to a file, folder, or volume of information that has been hashed. Hashing is a one-way algorithm. Mathematically, it is not possible to reverse the hashing algorithm and determine the plain text input that was used to create the hash. In this exercise, you will manually conduct hashing in both a Windows and Linux environment. So after completing this exercise, you should be able to conduct hashing in Windows and conduct hashing in Linux. So your devices, you will be using the following device in this lab. Please power this on now: ACI DC01, ACI Win11, and ACI Kali. So task 1, conduct hashing in Windows. In Windows, hash value can be computed in the command line using the certutl command for common hashes such as MD2, MD4, MD5, SHA-1, SHA-2, SHA-256, and SHA-512. In this task, you will manually compute the hashes in the Windows command prompt. So connect to ACI Win11, select File Explorer, and then this PC ACI HD, then Module 9 folder. Then in the File Explorer, type CMD, then hit enter. Then step 4, tap the following and press enter. So sir to till plus hash life space counter dot js md5. Note, the command conduct empted hash on the counter.js file. File kasi, lit. So lit. So cmd. So cert to till dash hash file counter dot js md5. So step 5, the command conducts an md5 hash on the counter.js file. So step 5, type the following. Again, sir to till dot hash file counter dot js sha1. So note the command conducts an sha1 hash on the counter.js file. So step 6, type the following and then press enter. So sir to till dash hash file counter dot js sha256. So note, observe the output of each hashing algorithm is a different length. The output length of MD5 is 128 bits, and the output length of SHA-256 is 256 bits. Close the command prompt window. So close the File Explorer window. Conduct hashing on Linux. So in Linux, hash value can also be conducted in the command line for common hashes such as MD5, SHA-1, SHA-256, and SHA-512. In this task, you will manually compute hashes in the Linux command line. So step 1, connect to ACI Kali. So if you're going to encounter again this, just reboot it. So once the ACI Kali is connected in the terminal emulator desktop toolbar, so step 2, in the terminal window, type the following and then press enter. So cd space documents slash module underscore 9 underscore folder. Then hit enter. So type the following and then press enter. ls slash dash la. So enter. So note the ls command list files and directories la designates that the display should use the detailed long format and includes all files including hidden and directories. Observe there are 3 files in the folder. In terminal window, type the following and press enter. So md5 sum my text.txt. So type the following and then press enter. So md5 space star then space then hash check dot txt. Hmm? So the star indicates that all files in the current directory should be hashed. The denominator sign directs the output in the MD5 sum. Yeah, no MD5 sum. The MD5 sum star and then hash check dot txt. So in the terminal window, tap the following and then press enter. So cat hash check dot txt. So note, observe the MD5 hashes for the 3 files in the current directory. So step 7, tap the following and press enter. So echo change my text dot txt. So the characters are used to append a string of the end of the file rather than which would replace the contents of the file. So the terminal window, type the following and press enter. So tail dash n1 my text dot txt. So by default, the tail command displays the last 10 lines of the files. The dash n switch designates the number of last lines in the displayed. In this case, 1, so only last line is displayed. Observe the string change has been appended to the last line of the file, and this change will change the hash output in the mytext file. So md5 sum mytext.txt. Enter. Observe the MD5 hash values of the unmodified and mytext.txt file and modified mytext.txt file are different. This indicates a change in the file that has occurred. So the terminal window, tap the following, then press enter. So md5 sum dash c space hash check dot txt. So note, the dash C switch instructs the command to check the checksums of the files against a provided list. The hash check the txt file. Observe the output indicates as expected that the mytext file txt file hash check has failed. This is because of the change made to the file. So step 11, type the following and press enter. So cat id my hash dot txt. Note, observe that there are 5 hashes in this file. The hash outputs are different lengths, indicating they may be using different hashing algorithms, but which algorithm is being used is not clear. So step 12, type the following hash id, then id my hash dot txt. So note, the hash ID command U is used to identify hash type. It is useful when you come across an identified hash value and want to determine which hashing algorithm was used to create it. Observe the output and discover for each identified hash. The hash ID command has provided a list of hashing algorithms that may have been used to create hash. Each hashing algorithm that were used to create the hash and the ID my hash text file are in order MD2, MD5, SHA-1, SHA-256, and SHA-512. So close the terminal window, then click next. So exercise 3, obfuscation. Obfuscation is a technique that makes the source code of an application difficult to reverse engineer. This is accomplished by applying various transformations to the course code, making it difficult for humans to understand while maintaining the code viability and functional execution, meaning that unobfuscated and obfuscated code both execute the same way, but the obfuscated code is very difficult for humans to read and understand. In this exercise, we will explore JavaScript code obfuscation. So learning outcomes, after completing this exercise, you should be able to execute JavaScript code and obfuscate and execute JavaScript code. So your devices, we will be using the following devices in this tab. Please power this on now. So ACI DC01, ACID Win11. So execute JavaScript code. Visual Studio Code is developed by Microsoft and is an open source code editor. It is lightweight, fast, and highly customizable, making it popular choice for developers using multiple programming languages. In this task, you will execute a JavaScript code using Visual Studio Code. So connect to ACI Win11, then select File Explorer, then navigate to this PC, ACI HDD, then Module 9 folder. So right click on counter.js, then select open with Visual Studio Code. So in step 4, Visual Studio Code, then always pop up OpenJS file and click OK. So open. In the Visual Studio Code window, select and run and debug icon from the left pane menu icon. Observe the code and discover that it is using a for loop to output a number to the screen, each iteration that starts with the number 1 and ends with 99. So in the window run debug run menu, select run and debug. So do you trust authors of the files in this workplace? Pop-up window, select trust workplace and continue. Then step 9, in the select debugger input field, select Node.js. In step 10, observe the output of running the code in the bottom right debug console. The output, as expected, is the number 1 through 99 written on the screen one at a time. So here, so 99. Then keep the Visual Studio Code windows open. So task 2, obfuscate and execute JavaScript code. Obfuscator.io is a website that offers online code obfuscation services. Developed source code may be uploaded and obfuscation techniques will be applied, creating obfuscated code that still executes the same way as the original of unobfuscated code did. In this task, you will use obfuscator that IO to obfuscate source code, then run obfuscated code in Visual Studio to confirm it still executes the same as the unobfuscated code. So connect to ACI Win11 where the Visual Studio Code window is open. So in the Visual Studio Code window with the counter.js script loaded, highlight and click on the entire for loop, then select copy. Then select the Microsoft Edge in the taskbar. Then the Microsoft Edge, type the following into the URL code and press enter. So obfuscator.io. So step 4, highlight and delete the default code, then right click and paste. So highlight, delete. Where? So once you have deleted and do the um, code, paste it, then scroll down and then select obfuscate. So note, observe the obfuscated code as expected. It is not human readable but should perform the exact same operations and result in the counting of 1 to 99 when executed. The obfuscated code has been pre-saved for you as obfuscated.counter.js. You may work with that file or you can create another file of your own with obfuscated code and use that for the remainder of this task. So select the File Explorer taskbar and then obfuscated counter.js, then select open, then open, and open, then close the counter.js file, then on the Visual Studio Code window in the Run and Debug menu, select Run and Debug. So this executes the obfuscated counter file, then Node.js, then observe that the output at the bottom right debug console discovered the obfuscated code and the original source code both execute the same file. So close the Visual Studio Code window. So close File Explorer, then close Microsoft Edge. So keep all the devices that you have powered on in their current state and proceed to the reviews section. Click Next. Well done, you have completed the data protection strategies practice lab. In this lab, you explore the data protection strategies of encryption, hashing, and code obfuscation. While these strategies are normally applied automatically by application, it is important to understand how and why they work. By conducting the operations manually, you have gained an understanding of this. Successful data protection protects data from cyber threats, maintains customer trust, and maintains compliance with law and regulation. So summary, you have completed the following exercise. Exercise 1 encryption, exercise 2 hashing, and exercise 3 obfuscation. So you should now be able to encrypt a file, encrypt a folder, conduct hashing in the Windows, conduct hashing in Linux, execute JavaScript code, obfuscate and execute JavaScript code. So feedback, shut down all virtual machines used in this lab. Alternatively, you can log out of the platform.